For the last few weeks, we've discussed feedback control, and we've found that feedback control loops are pretty good for lots of applications for a variety of reasons. The controller responds to any disturbance that leads to a perturbation of the controlled variable. Feedback controllers can be designed and tuned without models of the process using online controller tuning, and they can be retuned to accommodate process changes and to improve feedback control loop performance. But feedback control loops do have some limitations. For example, perfect control cannot be achieved. That is, the controller only acts when the controlled variable deviates from the set point. Perfect control would act to prevent the controlled variable from deviating from the set point. Feedback control could be improved if it could take corrective action for known disturbances, but it cannot. And it does not work well for processes with large time delays or large time constants. Finally, feedback control is not possible if the controlled variable cannot be measured. Of course, feed-forward control is an alternative, and it must also have some limitations, which it does. Feed-forward control can only respond to measured disturbances. And feed-forward control requires an accurate model of how disturbance variables and manipulated variables influence controlled variables. In feed-forward control, the ideal control law may also not be physically realizable. Let's take a look at some examples where we might use feed-forward control. Consider this boiler. The objective of this unit operation is to provide a constant steam pressure to a steam header, where the steam is a utility. Now, demand for the steam may vary, so the boiler will likely not operate at a steady state, as different downstream unit operations use more or less steam. But rather, it must keep up with the demand. The steam pressure and the water level should also be controlled. What are the drawbacks of using feedback control like this to control the tank level? First, this level control requires that we measure the level of a boiling liquid, and that level measurement may not be very accurate because the surface of the boiling liquid will be agitating turbulently. Second, if we're using feedback control, then the level controller is only able to take corrective action after the level deviates from its set point. If you were to propose a feed-forward control strategy, what disturbance to the level in the boiler might you measure? Think of it this way. What variable do you know will vary the most, influencing the level? If you said the steam flow rate, then you're correct. The steam flow rate is a disturbance on the liquid level in the tank. Even though this steam flow rate is downstream of the boiler, this is still feed-forward control because we're measuring a disturbance that affects the level, and then changing the manipulated variable to keep the controlled variable, the level in the tank, at its set point. If we know exactly how much steam is leaving the boiler, then we can predict how the level will change with time, and we can add exactly the amount of feed water in the makeup to account for the loss of steam from the tank. Now, if we were to use a feed-forward control loop like this, we would not want this to be the only controller for the liquid level, because it only measures one possible disturbance. There are other disturbances. What if the feed water pressure changes? Or what if the flow sensor fails? For this reason, we often combine feed-forward and feedback control loops, and there are various ways to combine them. Usually, feed-forward control is combined with some form of feedback control, where the feedback control ensures the controller will respond to unknown disturbances. One very common way to combine feed-forward control with feedback control is what we call feed-forward control with feedback trim. In this scheme, the signal from the feed-forward controller is added to a signal from a feedback controller, and the sum of that signal is sent to the control valve. The feedback controller can therefore still respond if there is an unmeasured disturbance to the level in the boiler drum, and the feed-forward control will help to balance the steam demand. In the next video, we'll look at another example, and we'll design a feed-forward controller for a blending tank.